Biasing in electronics is the method of establishing predetermined voltages or currents at various points of an electronic circuit for the purpose of establishing proper operating conditions in electronic components. Many electronic devices such as transistors and vacuum tubes, whose function is processing time-varying signals, also require a steady current or voltage to operate correctly, a bias. The AC signal applied to them is superposed on this DC bias current or voltage. The operating point of a device, also known as bias point, quiescent point, or Q point, is the steady-state voltage or current at a specified terminal of an active device with no input signal applied. The term is also used for an alternating current signal applied to some electronic devices, which is similarly required for correct operation, such as the tape bias signal applied to magnetic recording heads used in magnetic tape recorders. Overview. In electronic engineering, the term bias has the following meanings: a systematic deviation of a value from a reference value, the amount by which the average of a set of values departs from a reference value, electrical, mechanical, magnetic, or other force applied to a device to establish a reference level to operate the device. In telegraph signaling systems, the development of a positive or negative DC voltage at a point on a line that should remain at a specified reference level, such as 0. Note: a bias may be applied or produced by the electrical characteristics of the line, the terminal equipment, and the signaling scheme. Most often, bias simply refers to a fixed DC voltage applied to the same point in a circuit as an alternating current signal, frequently to select the desired operating response of a semiconductor or other electronic component. For example, a bias voltage is applied to a transistor in an electronic amplifier to allow the transistor to operate in a particular region of its transconductance curve. For vacuum tubes, a grid bias voltage is also often applied to the grid electrodes for precisely the same reason. A hot bias can lower the tube lifespan, but a cool bias can induce crossover distortion. Bias is also the term used for a high-frequency signal added to the audio signal recorded on magnetic tape. See tape bias. Bias is used in direct broadcast satellites such as DirecTV and Dish Network. The integrated receiver decoder box actually powers the feed horn or low noise block converter receiver mounted on the dish arm. This bias is changed from a lower voltage to a higher voltage to select the polarization of the LNB, so that it receives signals that are polarized either horizontally or vertically, thereby allowing it to receive twice as many channels. We still need to determine the optimal values for the DC biasing in order to choose resistors, etc. This bias point is called the quiescent or Q point, as it gives the values of the voltages when no input signal is applied. To determine the Q point, we need to look at the range of values for which the transistor is in the active region. Importance in linear circuits. Linear circuits involving transistors typically require specific DC voltages and currents for correct operation, which can be achieved using a biasing circuit. As an example of the need for careful biasing, consider a transistor amplifier. In linear amplifiers, a small input signal gives larger output signal without any change in shape. The input signal causes the output signal to vary up and down about the Q point in a manner strictly proportional to the input. However, because a transistor is nonlinear, the transistor amplifier only approximates linear operation. For low distortion, the transistor must be biased so the output signal swing does not drive the transistor into a region of extremely nonlinear operation. For a bipolar transistor amplifier, this requirement means that the transistor must stay in the active mode, and avoid cutoff or saturation. The same requirement applies to a MOSFET amplifier, although the terminology differs a little. The MOSFET must stay in the active mode, and avoid cutoff or ohmic operation. Bipolar junction transistors. For bipolar junction transistors, the bias point is chosen to keep the transistor operating in the active mode. using a variety of circuit techniques, establishing the Q point DC voltage and current. A small signal is then applied on top of the Q point bias voltage, thereby either modulating or switching the current, depending on the purpose of the circuit. The quiescent point of operation is typically near the middle of the DC load line. The process of obtaining a certain DC collector current at a certain DC collector voltage by setting up the operating point is called biasing. After establishing the operating point, when an input signal is applied, the output signal should not move the transistor either to saturation or to cutoff. However, this unwanted shift still might occur, due to the following reasons. Parameters of transistors depend on junction temperature. As junction temperature increases, leakage current due to minority charge carriers increases. As ICBO increases, ICEO also increases, causing an increase in collector current IC. This produces heat of the collector junction. This process repeats, and, finally, the Q point may shift into the saturation region. Sometimes, the excess heat produced at the junction may even burn the transistor. This is known as thermal runaway. When a transistor is replaced by another of the same type, the Q point may shift, due to changes in parameters of the transistor, such as current gain, which varies slightly for each unique transistor. To avoid a shift of Q point, bias stabilization is necessary. Various biasing circuits can be used for this purpose. Microphones. Electret microphone elements typically include a junction field effect transistor as an impedance converter to drive other electronics within a few meters of the microphone. The operating current of this JFET is typically 0.1 to 0.5 mA and is often referred to as bias, which is different from the phantom power interface, which supplies 48 volts to operate the backplate of a traditional condenser microphone. Electret microphone bias is sometimes supplied on a separate conductor.